We're back with day 55. I want to show you the balloon problem. Again, instead of this being in your notes, you can just put it in your homework, it's fine. So here's what we have. When we look at the picture here, we see a hot air balloon. That hot air balloon is going up. There's a little arrow indicating that. And a bicyclist is going this way. Okay. So once again, we have another right triangle problem. Again, what I like to think about on this problem is if the bicyclist is moving to the right, the balloon is moving up, what about the three sides of this triangle? Are they all changing, or is it just two of them changing? Well, obviously, the base and the height will be changing, but if they both change, so will the hypotenuse. Okay? So when I label this, right, and I'm going to label my picture. I'm going to call the base of the triangle X. I'm going to call the height Y. And I believe in the picture they labeled this S. I didn't put in any numbers here into my picture because all of these things are changing. So my picture, I want to have letters in for the things that are varying, numbers in only if it's not changing. But here, all three aspects are changing. What makes this problem tough is it's hard to calculate what our no is. Okay, the first thing they say is that the balloon is rising at a rate of 1 foot per second. Okay, we know that dy dt is going to be 1 then. We know it's a positive one because y is getting bigger in our picture. Now, what they said is, here's the part that's confusing. A lot of people want to put y equals 65. But if you read the problem carefully, it says that the balloon is 65 feet off the ground when the bicycle is directly underneath it. Well, we can tell from our picture that the bicycle is not directly underneath the balloon. Okay? This whole problem takes place 3 seconds later. That's the key. Okay? It says that the bicycle is traveling at 17 feet per second. Or I forget what the unit was. Let's go with feet per second. Okay. The question is, what's the rate of change of s, right? What's the rate of change of the distance between them 3 seconds after that scenario? So dy dt will always be 1. We know that's got to be true. Now, to figure out what y is, they tell us that the balloon was 65 feet off the ground when the bike was underneath. But 3 seconds later, how high would the balloon be? Well, the balloon gains a foot every second. So after 3 seconds, the balloon will gain 3 more feet of height. So y shouldn't be 65, y should be 68. Okay. We say that the bike is traveling at 17 feet per second. Okay, so we know dx dt is 17. We know it's positive because x is getting bigger, that dimension of the triangle. However, the bike is not directly below the hot air balloon, right? That was when y was 65. Again, we have to think about 3 seconds later. Well, 3 seconds later, every second, this bicyclist travels 17 feet. So he traveled 17 feet 3 times, so x has to be 51. Okay. We're starting to realize that when we do the Pythagorean theorem, it's nice when we know, in this case, x, y, and s. Right, you can either use a calculator here and do 51 squared plus 68 squared and do the square root. Or you can notice that 51 is 3 times 17. 68 is 4 times 17. So 5 times 17 is 85. So s has to be 85. What was difficult about this problem is the picture and the initial height they give you don't match up. We had to do a little calculating, no problem there. Our need then is ds dt. Okay, so we want to write an equation that relates these three. I thought about it in my picture and decided they should all be variables, so my equation should all be variables. X squared plus y squared equals s squared. Now I can do my derivative, and I got 2x dx dt plus 2y dy dt equals 2s ds dt. Okay. I'm going to make this simpler on myself by canceling out all of my 2's. I can just plug in. I know x is 51, dx dt is 17, plus I know y is 68, dy dt is 1. I know s is 85, and ds dt is what I'm trying to find. So on my calculator here, I would have to do this by hand maybe on a test. Just to save time, I'm going to do 51 times 17. I get 867. Plus 68 times 1. Definitely don't need a calculator for that. Equals 85. So 867 plus 68 is 935. 935 divided by 85. ds dt ends up being 11 feet per second. So on that one, we had to pay extra careful attention to reading that thing properly, right? To understand that y wasn't 65, because 65 was 3 seconds before when we needed it. Okay? That's it for today. A quick one. Make sure you finish up related rates 1 through 4, hand those in, and start plugging your way through that related rates review sheet. Getting ready for test on Friday. Talk to you guys later. 2 trains. Bye.